So just one note on perusal for this week. I'm going to switch up how things are set up there, at least for this week, see how it goes. There's a few articles that I've posted here as kind of the assignments that I want you to read. They're all linked at the end of these slides. Actually, 7.1, I'll maybe adding a few more during the week, just because I think it's more important that maybe we have discussions around these sort of fundamentals than maybe what's in the chapter per se, especially since we're doing labs elsewhere. So these are all three articles that are available online. Once you put annotations on them in perusal, you can read them in perusal, or you can read them on the original article link, whichever. But those will go over some fundamentals. So coming back to the slides, so we're getting into Unit 3. So far what we've focused on really has been the UI and focused on how do we work with different screens, how do we send intents and such to change screens. But our main focus has really been on the UI, right? So what we're changing now is we're going to be doing things more where we're kind of doing things behind the scenes. And this is a step towards being able to interact with databases and files, network tools, all sorts of other things that is really where we're going to get most of our data from. But in order to do those things, we have to not do them on the UI thread. That's an important part. So that's really what we're going over in Lesson 7, is a lot of ways that tools that you can do things outside of the UI thread, as well as responding and interacting with certain system events, which is 7.3. So that's kind of where we're headed now, right? We're dealing not directly with the UI, although we'll be doing a lot of interaction with the UI still, but a lot of this is stuff that we're doing kind of off the main beaten path. Okay. So 7.1, we want to talk about two classes that are available in Android. One is the AsyncTask, and then we'll also talk about the AsyncTaskLoader. That's kind of our main objective for today. We'll talk about those two things in kind of general, and then on Wednesday we'll go over 7.2, which is where we'll start taking that AsyncTaskLoader and using it with the internet. So we'll actually use the AsyncTaskLoader to pull things from the Google Books API. So you start to see some of the internet type things there. That makes sense? So, but today is just that fundamentals, okay? Talking about how do we deal with these threads? How do I do things in a background task instead of doing it on the main UI thread, which is an important part.
Sorry, I was going to wait.
So first we want to talk about what is a thread. So I talked a little bit about this on Friday, kind of getting us a preface to it. But the idea of a thread is it's code that you're running, right? So anytime any code that you're running is running in a thread. If I want to run more than one thing at the same time, I need to have separate threads. So this thread can be running one piece of code, the other thread can be running another piece of code. So it allows me to do things in parallel. But the thing you have to remember in that space then, they're also sharing memory. So you also have to worry about the gotchas with that, whether it be race conditions where they're both accessing the same piece of memory and cause a break where maybe the wrong answer ends up there, or you read the wrong answer, whichever case it is. So we have to deal with some of those things. The good news is working with AsyncTask and AsyncTaskLoader, it actually gets us around a lot of the race conditions, at least if we're careful with how we build our software. So it can mean that a lot of those aren't necessarily a problem. So with the main thread's job is to interact with UI. It takes care of drawing the screen. It's going to draw the screen roughly every 16 milliseconds. That corresponds to about a 60 hertz refresh, 60 frames per second. So that's kind of its goal. It's also in the process of dealing with all of the user actions. Anytime you click on a button, anytime you type a letter on the keyboard, all those things have to happen on the UI thread. Anything you interact with, whether you're changing something on the UI or you're receiving input on the UI, all of those things have to happen on the main thread. Same thing with switching activities. If you want to send an intent, open up a new activity, those have to happen on the main thread. All of your lifecycle methods, on create, on start, on resume, as well as on pause, on stop, and on destroy, all 6 of those, as well as on restart, have to happen on the main thread. So everything we've done at this point has happened on the main thread. It's not been an issue because everything we've done has been fast, right? So as soon as we get to something that's maybe a little bit slower, we're going to have problems if we continue that way. So what we want to focus on is how do we use another thread to do things in parallel while still keeping the UI thread free. So the way this kind of works out, if we're looking at the refresh rate and the way that things are displayed to the screen, we say, okay, we're going to do some updates. We're going to respond to an event, user clicking a button or whatever. We're going to do that work. And then hopefully we'll come back quickly and tell them, here's the new stuff. And as long as we get that under 16 milliseconds, that whole process under 16 milliseconds, there's no problem. The user's okay. Once I get past 16 milliseconds, we start missing updates. We start missing frames. And the user will perceive that as, say, stutter or kind of jumps or jagginess in your animations, right? So especially if you're running transitions, you'll see a really big issue there. Or if you're starting a new activity, all those things take some resources. But it's in general, you want to watch out for those things. Same thing with if the user's typing into keyboard. You really don't want to have their keyboard lag and they say, hey, they press a key, and then a second later they get to see the key show up on the screen. That we don't want, okay? So our goal is to get everything beneath 16 milliseconds. If it's not beneath 16 milliseconds, it's going to look bad to the user. Everything happens on the main thread. If it takes too long, if we pause or block the UI thread for too long, the current kind of setting for that is around 5 seconds. That can potentially change in newer versions of Android, but that's roughly what it is on most manufacturers at the moment. It's about 5 seconds. If you pause it for 5 seconds, you'll get what we call the Android non-responding error. We call it an ANR dialog. Looks like this. Okay? So you'll see that you see what it says. So it isn't responding. Do you want to close it? Right? So there's 2 options. Okay, wait. What do you think most of your users are going to click? Okay, right? Because your users have been trained to click OK anytime a dialog pops up. So they're going to click OK. When they click OK, it's going to shut down your app. So whatever they've done, wherever they've done at that point, wherever they are in your app, they've just lost all that state. They're going to have to start your app again. And the Android system won't start the app again. They'll just be dropped to their home screen. So they'll go, what the hell? So if you've got good users or friendly users that like your app or have some reason to continue using it, hopefully they'll restart your app and keep using it. But if you do this a few times or you have users that aren't terribly loyal to you, they get one of these and they'll say, oh, your app is garbage. Uninstall. You're gone. So you really, 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 really do not want to get these ever. You don't want to have these happen in your app ever. Again, the only way that they happen is you block the UI thread for 5 seconds or more. Okay, which is a pretty big gap from 16 milliseconds where we want to be to 5 seconds, right? So if we're anywhere in that ballpark, we've got a problem. That make sense? So that's one of the things that we need to avoid. So what are the kinds of things that we need to do in the background and that take a lot of time? Okay, so the big one of those is network operations. Anytime I need to go to the internet to do something, or my local internet, whatever I'm doing on the network, takes time. A lot of things on the network take on the order of seconds. So it may take you 3 seconds to go hit this website or download its results or things like that. That can happen. So if we get 1 or 2 of those, it's very easy to get us to that ANR point, right? Just 1 or 2 of those bad or long-running requests can get us to that point. So network operations are one. Also, by the same token, working with files. Working with files can take a long time. It does depend somewhat on the device that you're running with. Some devices can access files faster than others, but it also depends on how big that file is, right? If I say try to read a file that's only a few megs inside, it's probably going to load pretty quickly, but it will probably still load in more than 16 milliseconds. That makes sense? So a few mega file, it's still going to load in milliseconds, but it might be 100 milliseconds instead of 16, which is a problem. If I'm trying to load a big file, say I've got a gig or more, well, now I'm going to be talking about seconds just to read that file in. So anytime I deal with files, typically, you want to kind of guard yourself and do that in an async task like or AsyncTaskLoader, which we're talking about today. Long calculations can also be that sometimes. So the example that they gave in the chapter here is maybe you're calculating the next move in Go, right? The next move in a chess game, right? That may take some time, right? Or if you're doing some heavy image processing, you're doing any sort of large calculations that take a lot of time, that's something we want to do in the background, right? Most of the stuff we do is going to fall into the network operations space, whether it be interacting with a website or a web service, or whether it be going to talk to a database, right? So those things are largely going to be the things that we do in a background task, but it can also be things like fetching images, right? If I want to download an image, I may need to do that on a background task. That's one of the things Glide or Picasso already do for us. They do those processes on a background task. So processing images, loading data. Does that make sense? So large in part, it's anytime you go and leave your app, you're going to do something that's not bundled with your APK, it's probably slow. But there's just also algorithms such as figuring out the next move and Go, or even just graph algorithms and things like that that can take a long time. If you do decide to go in and play around with making video games in Android, that's a really important thing, because there's a lot of things in gaming that take longer than 16 milliseconds to do. Okay, so their general process for making this work, we're going to start with the main thread up top, and then we're going to kick off, anytime we've got long running work, we're going to kick off a new thread. We'll call that the worker thread in the background. So we're going to kick off that background thread, it's going to do the work, and then when finally it's done, it's going to report back to the main thread as sort of an event, per se. It goes into the event queue up here of the main thread, and it picks that up and says, okay, now I can update the UI, right? Because there's two rules. A, we don't want to do long-running stuff on the main thread, but we also don't want to update the UI on the background. So we need to use both. Okay? So we can do this with async task. We can do this with the loader framework. We can do this with services, which is one of the things that we'll talk about in lesson 8, is how to set up services. But we can also do this just with threads. There's a lot of bare concurrency sort of utilities that are built into Java, the language, that we can use to set up these background threads as well. In many ways, these async tasks and the loaders are really just a wrapper around those base concepts in an attempt to make it easier to work with. But you don't have to, per se, use them. Okay. So as I was saying previously, the two rules that we need to obey is don't block the UI thread. Whatever we do, don't block the UI thread. We've got 16 milliseconds at most, but that 16 milliseconds is shared between a lot of different things, right? So in reality, we may only have half of that to work with. Okay. We also want to make sure that we don't access any UI controls in that background thread. So we can't read the text in the text box. We can't say get text. We can't say set text. Okay. We can't change the progress of a progress bar or read the progress of a progress bar. We can't do any of those things. All of those things have to happen on the main thread. Do you have a hand up?
Yeah, so the 16 millisecond stuff.
Yep.
it's almost like arbitrary unless you can actually like kind of calculate that or just like see how long a certain function is running.
So it's not necessarily all that arbitrary. So the number 16 milliseconds comes from take a second divided by 60, you get 16 milliseconds because the 60 FPS thing, which there's a whole article that I linked and put up on. That's one of the articles that it's up on Perusal that you'll read through, and that's just about why is that 16 milliseconds a thing.
Mm-hmm.
There are profiling tools that you can use in Android Studio. I'm not going to be going over them because they're kind of advanced and a pain to use, and they're kind of beyond what we need for this class. But there are some profiling tools that you can measure how fast your code's going to run.
Okay.
In reality, most of the things that you do, as long as you're running, and we talked about big O notation and log and time complexity. If your things is constant, you're not going to need to worry about it. It's going to run under 16 milliseconds, no problem. It's anytime you get to linear or higher, right? That's where you start needing things that are going to need to go to another thread. Does that make sense?
Yeah.
So you can usually just tell by the time complexity. If it's a square n squared or n log n or n cubed or let alone 2 to the n, it's exponential. All of those kind of things you're going to have to push off to another thread. But if it's linear, if it's less than linear, you should be okay. Some linears will be fine, some linears will not be. So let's say I've got a list of 1,000 entries and I want to scan through and find a particular item in there. That's probably going to work in 60 milliseconds. Probably going to be fine. But if I say I want to scan through 1 million database entries, right, that's probably not going to fit under 16 milliseconds. Does that make sense?
Yeah.
So you can kind of guess by how big is that going to get, right? If it's something that the user has the ability to add more things to and could eventually grow up to, say, 1 million, if that's a feasible thing, then you definitely would want to push it off there. But if you know for sure that this is never going to get above, say, 100, right? Maybe you have a spinner that only at most has 5 things in it, no big deal. Right. So if there's a definite upper limit that you can specify that's probably under 1,000, you're probably okay. You probably don't need to worry about it.
Cool.
Does that make sense?
Yeah.
Versus if you are loading a file, it doesn't matter where the file's coming from. It doesn't matter how big the file is. You should do it in background. Same thing with network resources. So how does the async task work and deal with this idea of running things in background? So the way an async task works, this is a class that's built into the Android framework. We create it in the main thread, or start it in the main thread, and then we need to kind of override 2 methods in there at minimum. So the first method we need to override or implement is doInBackground. That's the code that's actually going to run on the background thread. All the other methods, there's a few other methods on async task that are all going to run on the main thread. So we kind of have a way to go back and forth. So first doInBackground, that's where we're going to follow the code that happens in the background. onPostExecute then gets called back on the main thread once doInBackground finishes. Once it reaches the end of this method, we'll come back to onPostExecute, and that will be back in the main thread. So I kind of do all my calculations, my downloading, my file loading, my grabbing images, whatever I need to do that's long running, I do it back here, not touching the UI at all. And then once I get done, I can come back to onPostExecute and modify the UI. So whether that means showing the image that we loaded, showing the contents of the file, populating a recycler view, all of those kind of things, updating a progress bar, updating a text view, all of those things we'll do back in onPostExecute. So that's just how we break those 2 things apart. Now, one of the things that means is you do have to be very careful with what you do in doInBackground. Namely, you really want to avoid usually calling methods on your activity, because a lot of methods on your activity will be touching UI components, right? There are very few methods that we ever write on an activity that don't touch the UI. So if we want to do this, we're going to need to extract potentially some of our business logic out of the activity. Same way we might need to do with unit testing. In fact, doing some of this work can push you towards code that's easier to unit test, simply by getting it into a background thread, because you start to have to think about those things. And that's the other reason why we do that. So doInBackground, that's where we're running our background, our actual background operation. onPostExecute runs immediately after, when the work gets done. Whatever doInBackground returns gets sent to as an input to onPostExecute. So if at the end I say return the total size of this file, onPostExecute will then have that total size. Okay. There's also some other methods that we may need to implement. So onProgressUpdate runs before doInBackground. So that's work that we need to do to set things up. Commonly, that's things like showing a progress bar. So usually if we have a progress bar that we're using, we'll show it in onProgressUpdate and then remove it in onPostExecute. Does that make sense? Show it in pre, hide it in post. We also have in between there, we have one called onProgressUpdate, and that allows us to give intermediate changes to the UI. So say we want a progress bar that you're downloading a file from the internet, we want to show the user that it's actually doing something. So if, say, every 10% you download, it updates it. Well, we can do that in onProgressUpdate. That makes sense? So onPre is at the beginning. That's where we talk to the UI. onPostExecute is at the end, and then our progress update is in the middle. And we kind of can look at that in this diagram here. So on the main thread, all three of those methods run on the main thread. The only one of these methods that runs in the background is actually doInBackground. In order to do progress updates, we have to actually call a method in doInBackground called publishProgress. So if I call publishProgress, that's going to put kind of an event on the UI. Eventually, the main thread will pick that up and show the progress, calling onProgressUpdate, right? So that's how we pass progress along, is we call publishProgress. So I will say, hey, I want to publish progress. It's 3%, so I send 3 into that method. I receive the 3 in onProgressUpdate and show it into the progress bar, or whatever it needs to be. That'll make sense for how the workflow is. Again, the important thing to remember there, the only thing that's run on the background is doInBackground. Everything else is still on the main thread. That's usually one of those things that trips people up the most when working with it. So in order to actually create an async task, the first thing we need to do is create a subclass of the async task class. Now you can do that either as a nested class inside of your activity, or you can do that as a separate class. The labs will have you go through and do that as a separate class. So that's kind of my expectation, and that's what we'll go through here. There are some benefits potentially to doing it as a nested class, but there are also a lot of pitfalls. So if you want to be kind of safe, move it to an outside class. So when we're creating that subclass, AsyncTask is actually generic. It's actually a generic class. So it actually takes 3 different type parameters, which may seem kind of weird because we've probably never seen that many type parameters. But they're really important. You want to make sure you get these right before you implement the methods. Otherwise, you'll basically have to throw all your code away and implement the beginning. So make sure you get those right to begin with, because they affect a lot of things. So the first parameter, when we're seeing URL, that's the inputs. Those are the inputs that are going to come into doInBackground. Okay, we call them the parameters. Okay, the second thing is the type of progress data, the data type we're going to use for progress events. So anytime we publish progress, we're saying we're going to send an integer, and that's what we're going to use. So I might say, well, 0 to 100 for, what the percentage of the files have downloaded. Or I might say, I've downloaded 500 bytes or 100 bytes. So this integer could be bytes, it could be a percentage from 0 to 100, or it could be how many steps have I finished, right? Maybe I have a 20-step process, and this is, okay, so it's 0 to 20. So that can really be anything, but we have to tell it what data type is it. Okay. And the final thing determines what we get out at the end. What is the result of this operation? Right? So at the end of this, according to the signature, we're saying we're going to be getting a bitmap out of it. Right? So I can kind of even just tell from that signature what type of thing I'm doing. Right? So if I'm taking in a URL, what does that probably tell me about what this operation is going to do? Okay, so we go out to the internet, get something that has a URL. Okay, and then our progress is based on integers, so I'm probably going to give you the percentage of the file that's downloaded in some sort of progress bar. And then looking at the end, well, we know we're loading a bitmap. So we're probably loading a bitmap from the internet. Probably loading an image from the internet is what this is doing.
So those three things can change depending on the view?
Yeah, they can be anything.
Okay.
They can be absolutely any type. Anything you want them to be. Any subclass of object, that's the only limit.
But it's always in the order of like data, progress,
Parameters, progress, and result.
result.
Yeah, parameters, progress, and result. Always have to be in that order. That's important to do that first because all of the methods that we look at now, those data types are going to be substituted in several places. So it's going to be the return type or the parameters for all the callbacks that we give.
So sorry, I'm on the,
yeah.
I moved up to the next slide. The stuff, the generic types you put into that async task correspond with the overridden methods that you override in your subclass? Yeah.
Yeah. These three types change the signatures of those methods. So we'll see that in a minute. But yeah, it does change the signature of each of those methods. Important note here, you can use the void type. Note it's got an uppercase V if you're not using that particular piece of it. So if we're not, say, we don't have any input parameters, which is actually pretty common, you might put void. If you're not giving the user any sort of intermediate results, you can put void there. And if for some reason you're not giving an output, you can put void at the end, but that doesn't happen very often. Usually these first two might be void, but the last one very rarely is, because usually you want to get something out of this whole shit. Graham, did you have a question? Huh? Yeah, so if you were telling it to send out an email and then you're not bringing anything back to the UI, that would make sense. Yeah, so there I might say void, or I might say string at the beginning to say, give me the email addresses, void because I'm not going to tell you how many you're sent, or I could do integer and tell you how many of the emails that you asked me to send, and then I'd probably, yes, I would have void at the end because I don't necessarily have anything to tell the user at the end. It's just like, it worked. That's all I need to know. So first, to implement onProgressUpdate. onProgressUpdate doesn't take any parameters. It returns void, regardless of what data types I've written previously. Actually, before I do that, let's see, is there anything else I needed to talk about here? Nope, we talked about all that. So in onProgressUpdate, that's where I'm going to use setup. Again, the most common thing to do here is to show a progress bar and set 0%. That's the most common thing that you're going to do in the onProgressUpdate. But you could also say show a toast to say, hey, the process has started. We're doing it. I'll get back to you later. Or it could be a snack bar or toast, either way. doInBackground is that next one, so that's where we're going to be doing our actual work. So we might say, write all that logic to download bitmap from the internet using the parameters that I have here. So here I have string.query. Okay. So I'm taking string was my input, so that was my params. So whatever's here is params dot. Now that dot isn't really something we've talked about. We might have talked about it briefly in the syntax run notes, but we really haven't said too much about it. Any guesses to what that means?
parameter array, I think.
It is a parameter array. Yeah. So if you remember in C#, we wrote that as params string query, right? So that dot 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 is basically the same thing as the keyword params in C#. So I can, when I call this method, I can call it with any number of arguments. And it's going to come in effectively as array. So this data type, even though it says string dot dot, once you're writing this code, you're going to treat it as a string array. For all intents and purposes, it is a string array. It only affects how you call it. Does that make sense? Which we don't call doInBackground directly. That's the framework that calls that, so we don't even really need to worry about it. It's just going to be a string rel for everything we do. We do have to write it as dot 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 to go with the interface. Okay, so along that process here, I might say maybe I have a loop to download that image. I'm probably going to have some sort of while loop that says read some bytes, then read some more bytes, and then read some more bytes. And every time I kind of get a chunk of bytes, maybe I send a progress event to say we're this far along the way. So I might do publish progress. Usually after I do publish progress, it's going to be in some sort of for or while loop. I typically don't do it immediately at the end. It's somewhere in the middle. And then finally we return the thing that we found. So we wrote all our logic to download the bitmap. Finally we return that bitmap. Or whatever else our result is. So that's the kind of general structure of it. So you'll notice the two things that change here. So this here in doInBackground, that's our params data type. And this right here will be whatever a result data type is. So when we're implementing that class, that's part of why we need to put those data types in first before we start moving into implementing the methods. Because it's going to affect the parameters and the return types. So it takes strings and it returns bitmaps. If you have different data types there, it's going to tell you you're not implementing the interface or you're not implementing the async task. Okay. onProgressUpdate. onProgressUpdate on a similar note takes args integer. Right? So it takes parameter array of integers because again that's a parameter, that's our progress data type. So we're going to take that effectively as an array. Here they're saying, well, let's take the first item and show that to a progress bar using this set progress percent method. That's not a method that's built in. That would be one you'd have to write yourself. But that's usually what we do. We'll usually write a method to update the progress bar because we may need to use that in multiple places. Okay, and then finally onPostExecute is going to take that result data type and then display it to the UI. So that's kind of the rough sketch of those methods. Does that make sense? Remember what are the two methods in there that you have to implement in general? And onPostExecute, right? Those are the two that most of the time you need. Typically you don't have to do, and a lot of times you don't necessarily have to implement the other two. But to do most useful work, you have to implement doInBackground and onPostExecute. Okay. So let's say we want to kick off this task. We've created our AsyncTask subclass. I called it my AsyncTask. It takes in, remember, it takes in a string, or we're taking in this query args, which actually, I think that's in the wrong place. Yeah, that is in the wrong place. Because that should be down here. So here we're saying, here I've got a load image method. By the signature of it, you can kind of guess it's probably going to be back on the activity, right? So this is maybe responding to an event. So you click on a button, we're going to call load image, and then we're going to say, okay, well, let me go grab the text that you typed in, and I'll pass that off to my async task to go try and download that image, right, based on your search term. So let's say you type in cats, it's going to go look for cat images. So we say create the new task, and then we execute it, passing in the parameters there. Okay. So whatever I pass in to execute is going to end up in doInBackground as our parameters. I can also do some of this logic in the constructor. It kind of varies depending on where you need to do the work. So sometimes it's worth passing in these parameters to the constructor. If it's kind of quick, you're just going to save the values. But if it's something that you need to do some work with then immediately, it may make more sense to pass it into the execute method. But you can work it either way. Another important thing I would suggest, the book doesn't have you do this. They just say new async task and then immediately execute on one line. It's usually worth saving the async task to a member variable so that if you do need to, you can cancel it later. So say the activity gets destroyed, if you don't save that task object, you have no way of killing it. But if I save it to a member variable, then I have a way of canceling that task rather when in the on-destroy method. Does that make sense? So typically with this, we'll want to cancel any running tasks and on-destroy. We also may want to say if the user clicks the button again, we want to cancel the previous task and start the new task. So that's, for both of those reasons, it's usually worth saving your task into an instance variable. You don't have to, but you'll have a lot less issues if you do. So there are a few limitations with the async task. One of those is anytime you change the configuration of your device, while the activity is destroyed, your task is not. So remember, if I turn it from portrait to landscape, remember it destroys the activity and completely recreates it? Well, that will lead to the activity being destroyed, but it doesn't lead to the async task knowing anything about it. The async task out of the box has no idea that your activity's been destroyed. In fact, it will gladly continue running through its doInBackground, get to the end, try to call onPostExecute, and it'll try to update the old activity, which will probably result in an exception, but may not. Either way, the user won't see what's happening, so usually you want to, again, cancel that activity when your activity is cancel that task when your activity is loaded, just for safety's sake. With that, what that means is oftentimes, let's say we think about your list of articles that you had. You had a list of sports articles and such. Remember that we did, what was the name? It was the Material Me project. Remember you had Glide loading those images, right? So if you're just doing that with an async task out of the box, what you're going to find is that's still continuing to load all those images even after you turn it to landscape. So now, well, what's the first thing I need to do when I show it in portrait? Well, I want to load the images. So I'm still loading the images from portrait. It hasn't stopped. And now I'm also loading the images for landscape, right? So that's a problem, right? If I don't cancel or I don't stop those previous running tasks. So I make sure I do that as much as I can. If I don't do that, again, we're going to lead into memory leaks. We're going to lead into all sorts of problems because those tasks will still be running. And they'll still have access to potentially some of your UI controls, which means that if you've got a task referring to any of your UI controls or any of your activities, those activities and those controls cannot be garbage collected. Anything an async task has access to in a member variable, local variable, whatever it may be, that cannot be garbage collected. Okay. So let's say I have 100 articles showing up, right? Okay, so each of them have an image. I start up 100 async tasks to load those images. I turn it landscape. Now I need another 100 to go load those images. I turn it back to portrait. Now I have 300, potentially 300 tasks going and loading images, right? That can easily be a problem, right? So you do have to be very careful with how you use these. And that's one of those reasons where you may want to use something like the cost over glide to kind of take care of those issues with loading images, just because then you don't have to deal with those. They've already thought through a lot of those issues and resolved them. Maybe not all of them, as we've seen with glide does have some issues, but they've at least thought of some of them that you might not think of. So in general, historically, AsyncTask was recommended for anything that was short, interruptible. I don't really care if it finishes or not. I just want to say, okay, go do this quick thing, and if you don't get done, no big deal, right? So that wouldn't be something like loading an image for every article. That would be something like doing spell check on your text message or your article that you're writing, right? That might be something you're okay. I'm fine, So there might be some of those things that you're okay with just kind of leaving it unfinished. Maybe it only takes a few seconds to finish. You're doing background work. Yeah, okay, so in a few seconds I'll have that memory back. But if you're having long-running things or you're spinning up a lot of tasks, then it's going to be a problem. So in those cases, AsyncTaskLoader is recommended as being better. It's better to use a loader for a lot of these long-running tasks because they handle some of these issues better, such as, again, recovering from the configuration changes with orientation or language switching or all of these kind of things. So AsyncTaskLoader is generally recommended over using AsyncTask. Good news is AsyncTaskLoader is a little bit simpler. It's actually potentially easier to implement it than the AsyncTask. So that's good for us. One important thing to know, this has happened very recently, so your chapter doesn't talk about it, but if we go look at the AsyncTask class itself, I'm going to follow this link. Do you see this message up here? Let me see if I can make that a little bit bigger. As of Android 11, AsyncTask will be deprecated. So Google's actually in the last year, just relatively recently, this may be the last few months that showed up there, they've decided that, well, there's no good case for using AsyncTask anymore, effectively what they're saying. So historically, there's a lot of stuff that we did with AsyncTask. They're saying now it's time to use other things. That's a big shift. You'll probably find, if you are working on Android apps, you'll probably find a lot of places where they're still using AsyncTask, which is part of where we're still going over it, as well as it's kind of an easy intro to some of the other resources that are out there. And on the other side, if you're ever doing something in C# with, say, Windows Forms or WPF, there's a class in C# called background task. It actually works basically the same way as AsyncTask. So if you're doing things in C#, again, with desktop apps, a lot of other frameworks have the similar sort of thing. The things you learn here are actually more broadly applicable than just Android. Because most desktop apps and even potentially some websites, if you're working in JavaScript, you may need to do some of these kind of things as well, where you're working with background tasks. So the way this top sentence here is kind of the part that's new on this description. So this is Google's kind of wording on why is it deprecated. So AsyncTask was intended to enable proper and easy use of the UI thread. However, the most common use case was for integrating UI, and that would cause context leaks, missed callbacks, or crashes on configuration changes. It also had inconsistent behavior on different versions of platforms, swallows exceptions. So if you have an exception that you don't catch and do in background, it just goes away. And it doesn't provide a lot of utility over executors. So executors is something that actually goes back all the way to the world of Java and is brought in. And so the reality is a lot of the things that AsyncTask does can be done better without using AsyncTask. It was meant as a way to make things easy for people that are not really skilled at Java and Java's threading model and understand all the concurrency things that go with Java. But unfortunately, it doesn't provide much, doesn't usually make things significantly simpler over just using those underlying things that AsyncTask was built on top of. So that's their recommendation now. Their recommendation is to go back to the java.util.current concurrent package and use those classes largely over the AsyncTask class. There's also a class in Android called Handler. Handler, the whole point of Handler is to get events from a background thread to the UI thread. That's what it does. So you can say start a thread, use a handler to pass those events over, or executors or things like that. There's a few different ways to get your data from the background thread to the UI thread. Okay. Any questions on that? So that's kind of where the world of Android is there's a big shift coming with all this background stuff. And you'll also see, if you look at the documentation on loaders, there's some which is what we're going to talk about now. There's in a minute is also there's some changes happening on that side too. So there's a lot of big changes dealing with concurrency that are coming down the pipe with Android. Let's go ahead and take a quick break. We'll come back at 1:35 and we'll resume and talk about loaders. So before we left off, we were talking entirely about async tasks and how to use async tasks to run background processes. That's going to be entirely what your lab for 7.1 is about. So your lab, your tasks, the homework, the coding challenge, all of those have to deal with the async task. So for 7.1, there's actually no labs about loaders. We're going to talk about them right now. But just fair forewarning, it's something you're going to have to kind of keep in the back of your head and think about. We'll come back to them on Wednesday when we go over 7.2. Then we'll really dive into how to use a loader. So your lab on 7.2 is going to start getting you into async loaders, but for 7.1, it's just going to be about tasks. Okay, so let's talk about what a loader is. To kind of explain, kind of from a theoretical perspective, how to use it and how is it different. So the big upside to using a loader over async task is that it can respond better to a configuration change. Again, configuration change meaning orientation changes, meaning language changes, meaning other device changes from the size of the device, different things like that. So it responds better to that because it's able to resume from a previous kind of a started loader. It's able to pick up from where a previous loader left off, rather than say, you want to download those 100 images, well, I'm still going to probably load up. I might need to load up maybe one loader, and that one loader might actually be able to do all of that, all depending on how I set it up. But that loader will be able to resume once we change orientation from portrait to landscape, rather than losing all that progress and having to start from the beginning. So it's better at that, because there is a way to reconnect. Okay. It provides us with a way to do asynchronous loading of data. It really actually can be anything. You can do anything that you would do with an async task, you can really pretty much do with a loader, minus the ability to really give progress updates. That's the big thing that you lose with a loader, is you lose kind of that ability to publish the progress along the way, to say we're 50% done, 75% done, etc. So it gives us a way, we can use it to monitor changes in the original data, update the UI with it. That can happen if you have, say, a long-running loader. It might watch for different things, for different changes. The way that the data gets back is implemented a bit differently. So remember with the async task, all those methods that we overrode, they were all part of the async task class. Does that make sense? They're all part of the async task class. Well, with a loader, basically the doInBackground is a method we override in the loader, but all the other callbacks, all those other methods, actually are back in the activity, which actually kind of makes the code a little bit easier most of the time, makes code a lot simpler. So the way that that happens, we have these callbacks. The callbacks are back in the activity. The activity will generally implement this callback interface. So it's going to respond to this back in the activity instead of responding to when the task finishes over in the async task. So there are two basic loader implementation, two loader subclasses that exist in the framework. One of them is AsyncTaskLoader, and the other one is CursorLoader. So AsyncTaskLoader is a subclass of loader. CursorLoader is a subclass of AsyncTaskLoader. So when we're dealing with loaders, one of the big class that we'll start with is the LoaderManager. LoaderManager is what it says in the box. It manages your loaders. It keeps track of where they're at in the process. It helps you with starting them and continuing them on and reconnecting them from one configuration change to another. So your LoaderManager is what does the brunt of the work, and that's important because you can kind of push that work off there versus if you were doing it in an async task, you typically have to kind of manage the life cycle of your task in the activity. So the LoaderManager kind of deals with those things. Yep. Okay. So again, loaders like async tasks generally run their work off of the UI thread. They're going to run it on a background thread. They make more efficient use of the framework than async task does. And it's still a way for users to kind of not have to wait for their data to load, similar to how the async task works. Okay. So as kind of mentioning previously, the way that the manager works, the manager is actually kind of the go-between between our actual loader object and our callbacks. So we'll actually say, okay, manager, we want to start a loader, and here's my callback. Tell me when you're done. It can manage a bunch of different loaders, that loader manager. It doesn't have to be just one task running. It can be anything. So it could be you have one loader to load data from the database. You could have another load to load files from the device or images or whatever you need to load. And you could have a third one for loading stuff from the internet. You might actually have a lot for loading it, more than one for loading stuff from the internet. So the first thing to do if we want to use a loader is we have to get the loader manager and then start it, initialize it. So the first line of code, you're going to put this in onCreate. Is your component called get support loader manager initLoader. That's the first line of code that you want to put in. And that always needs to go into onCreate. Okay? Again, that's if you're using loaders. If you have a screen that doesn't need loaders, you don't need to put that on onCreate. But if you're using a loader on that screen, so initLoader takes 3 arguments. First is the ID of the loader. Next is any arguments you want to pass to the loader. And the third one is the callbacks. So who needs to know when the loader finishes? Okay. So typically that's going to be this, in the sense that it's referring to your current activity or maybe even your current fragment, because you can also do this from inside of the fragment, which is great. So this doesn't have to be just an activity thing. This can be in a fragment. You'll want to call get support loader manager because there is a just get loader manager, which is the framework one, but kind of like async task is in the process of going through some deprecation and changes, and you've seen the whole Android X Jetpack thing. So the built-in loader, all the loader classes from the loader manager to the AsyncTaskLoader, all of those has actually been deprecated in APA 28. and they moved all of that stuff to the support library. So if you want to use loaders, you're all going to use them from Android X instead of using them from the framework, which means that you need to call get support LoaderManager, not get LoaderManager. You can also, the other thing to know, in these arguments that we pass in, these are only given to the loader the first time. So the point of that is, here's your job you want to do. It will then pick it up and use the same arguments the second time. So if I need to change what task is running, let's say I want to cancel the previous load and start a new load, I do need to call restart loader instead of initLoader. Okay, initLoader is going to try and pick it up if it's already running, versus restart will force it to start from the beginning. Okay, so if you're downloading images, downloading things from the internet, it's probably most of the time going to be that you just want to call init. But if you're saying, okay, well, the user, maybe there's a user query, the user types something in a text box that you need to send to the server, well, if that's changed, obviously you'll need to call restart to go get the new resource if the arguments have changed. But typically in onCreate, we'll just call initLoader. Okay. So how do we implement an AsyncTaskLoader? So there's a lot kind of going on. There's a lot of moving parts in an AsyncTaskLoader. An AsyncTaskLoader, at least in the current implementation, does have an async task kind of built into it that's actually running the work. You don't actually directly interface with that async task, but it is there. Okay. So inside of the async task, we kind of have that part. So where we start, we're working with this. So we'll start with the activity. The activity is going to request some work to be done. So it's going to tell the LoaderManager, I want you to do some work. That's then going to cause an async task loader to be created. Actually, that kind of part of the activity's job too. But basically, the LoaderManager then creates the loader. The loader then uses the async task to kind of go do the work. And then once the work's done, it comes back. The activity gets the finished work. So it's the activity's job both to start the loader as well as receive the finished work. That make sense?
Is AsyncTaskLoader deprecated?
AsyncTaskLoader, so that is deprecated as of 28. So it's Android R for the async task, but it's 28 for AsyncTaskLoader. Yeah. So it's not deprecated if you're using the support library. So AsyncTaskLoader is not deprecated if you're using the support loader. As far as I know, AsyncTask is not per se in the AsyncTask by itself is basically they're recommending that you completely move away from AsyncTask. It's still okay to use AsyncTaskLoader. What they've decided to do is stop shipping it basically with the core Android framework. And the other thing that happened, because the support version is actually pretty old, it was actually introduced in Android 4. Because prior to 4 there wasn't an async task or AsyncTaskLoader. I think there was an async task, it was on back to 1, but AsyncTaskLoader started in 4. So that's been around for a while, the support version to kind of fix older versions, but with the Jetpack they've decided to take some of these things. It's like, we really want the users to be able to plug and play, and we want developers to decide what they actually want in their app and what they don't want in their app. So it basically means that they're not forced to build in AsyncTaskLoader is no longer part of the core framework. It's part of a support library, which means you can continue using it, but it's not part of the core. It's going away from the core, if that makes sense. So the way that we kind of translate this, we talked about how to build an async task. The main methods that you have to implement are doInBackground and onPostExecute. With an AsyncTaskLoader, there's kind of a direct corollary to those two. So what we had in doInBackground will now be in LoadInBackground, which is part of your loader subclass. So you'll implement LoadInBackground instead of doInBackground. And then onLoadFinished is basically where I put the logic that would have been an onPostExecute. But the onLoadFinished is part of the callback.
So we don't do anything with AsyncTask, we're working with AsyncTaskLoader Overview.
Yes. That's how, if you're working with AsyncTaskLoader, you don't touch the AsyncTask directly. Again, your labs are still going to have you go through AsyncTask. So your all of 7.1 will ask you to go purely AsyncTask, no task loader. Then towards the end of 7.2, they'll convert it over to the program we make in 7.2, they'll convert it over to loader. But for now, for today through most of Wednesday, you'll be working with just AsyncTask and not loader. But this is kind of where they put the theory, at least. Part of that is there's a lot of theory in 7.2. There's a lot of additional stuff that we have to talk about because we want to talk about how do we get stuff from the internet. There's a lot that goes into it. So in order to create an AsyncTaskLoader, we need the subclass AsyncTaskLoader. Similarly, how we had the subclass AsyncTask, but now we're subclassing AsyncTaskLoader. We need to implement a constructor for that loader. We need to implement the doInBackground, and we may need to do some work in onStart loading. This is somewhat optional. So to go through that, so in order to create a loader, I'm going to say extends AsyncTaskLoader. Now, the nice thing about the loader instead of the AsyncTask is it only needs one generic argument. Okay? Remember when we were building an AsyncTask, we needed parameters, we needed progress, and we also needed a result. With the loader, you only need the result. You only need to know what does it produce when it's done. So in this case, we're producing a list of strings when we're done. Okay, so that's our return type. They call that D, or data, or data type. Okay, so we've got a constructor. It always has to take a context because that's what the base, the parent class needs. It needs a context. So it'll always be your first parameter to an AsyncTaskLoader. Your second argument, or third, fourth, all of that's completely up to you. That's whatever data you need to start the task with. So in this case, we need a query string as our data to start the task. Okay, because this is going to be going and looking for some strings somewhere, doing some sort of searching. So I need to know what are your search keywords or whatever. Okay, so I'm going to save that. That would go to, I don't know why they don't have it on here, but that would go to an instance variable with mQuery string in this case. So that's my constructor. And then I need to implement doInBackground. So doInBackground doesn't take any parameters because I've already taken the parameters in the constructor. But it does have a return value. You can see here it's list of string, right? Because when I implemented the interface, I said that that was the return type that I was going to use. So whatever I use there in the type arguments, whatever I use here is what doInBackground needs to return. So I said list of string, so this needs to turn a list of string. So here I'm saying, well, let's create a new array list. Let's do some work to grab those strings over the network or the database, and then we'll return. Right? We're not talking about the code here in the middle today. We'll talk about that on Wednesday, about what might be put in the middle there to actually get it from the network. And then Unit 4 will come back and we'll talk about, well, how do we do that from a database? But that's the basic structure. So as far as implement the loader interface, that's typically all we need. We need to implement the constructor there, and we need to implement doInBackground. So our loader classes end up being a little bit, usually a bit shorter, a bit simpler than our AsyncTask classes because there's just less logic there. Okay. Now, coming back to another method that you may need to implement, there's a method called onStartLoading. So onStartLoading is called from restart loading or initLoading. and it's called in response to that from the LoaderManager, and it's called to kind of check, do you need to restart? Things may have changed. Are you good, or do you want to start from scratch? So if you just leave it empty, you'll just be resuming where you were, but you may have some logic where you need to check, hey, if I cached or saved the previous results, has something changed with the new inputs that I need to rerun it? So on start loading, you may want to call force load, which is going to force it to start again from the beginning. If you don't call on force load, it will resume from wherever it was. Okay. Now, coming back to the activity. So that activity needs to implement the LoaderManager.Loader callback method, or sorry, interface. So we're going to implement that interface. You can see it's generic again, so we have this D at the end. That's the data type that we're returning. So what was the data type for the task that we just created? List of strings. So when I'm looking at the activity, you'll also see list of string over there. So that interface has three methods that we may need to implement. Okay. So the first one is onCreateLoader. That's called right after we start a loader. That's what actually goes and creates the loader object. Okay. That's how we actually start the loader. We'll say initLoader. It will then call onCreateLoader. onCreateLoader returns the new loader object, and we're off to the races. So that's how we start. onCreateLoader is the first method that gets called. And then onLoadFinished is what gets called when we finish the actual load. So once the data is available and ready to be used, we'll call onLoadFinished. So typically that means, hey, you get to a screen, user maybe pushes a button, that will start the loading process. When that finishes, then we get to onLoadFinished. If you were to say, turn the screen sideways in between, well, then onLoadFinished will be called on the new activity instead of the old activity. If you get into a case where, well, you've hit the button, it's loaded it, it's finished, you turn it sideways, is go ahead and call onLoadFinished on the new one anyway, so that it knows that, hey, it's done. So you're going to get that whether or not it finished it before the orientation change or after the orientation change. You'll get it in both cases. There's also a final message called onLoaderReset, which is called anytime you kind of restart a loader. Typically, there's not much that we need to put in. Typically, we're going to leave that one empty. So onCreateLoader has this sort of signature. It's going to return a loader of that type. So we said that we are working with lists of strings, so it's going to return a loader for a list of strings. Okay. And it needs to take two things. So it needs to take an ID. That's the ID for the loader. Remember when we called initLoader, we passed an ID. Could be really anything. We passed 0 in that particular case. So 0 will be here. So that ID is used to kind of track if you've got more than one loader running, which loader is it? So I might say loader 0 is for downloading a list of articles from my website. Loader 1 is to download the images. Loader 3 is to do something else with the database, right? So that's kind of to tell me which loader I'm working with. And then the arguments are also things that we're going to pass on to the actual loader as data. So both of these things, the ID and the args, are things that we pass to either initLoader or restart loader. That's where they come from. Okay. So in here we say this is a very simple sort of implementation. We only have one kind of loader, so we're just going to say return new string list loader. Create a new object of it, pass in the activity, which is the context, and then give it the arguments. Give it that query string that we passed in previously. So I pull it out of the bundle, pass it on to that constructor. So that's onCreateLoader. It's usually going to be about that simple. Okay, then onLoadFinished is where we typically have the vast majority of our logic with this. this is where we get, okay, I've got the results back, here's the loader, and here's the data that it returned. I'm going to then go display that data in whatever way makes sense. So in this case, we've got some sort of adapter view or recycler view, and I'm going to say, okay, tell that adapter that there's new data. So I'm going to say adapter.setData, here's the new data. Again, that could be a list view or that could be a recycler view that's hooked up on. Okay. Onload, again, called if there's a loader that's destroyed, and if we need to do any cleanup, but usually we can leave that back. We do have to implement it because it's part of the interface, callback interface, but we can usually leave it blank. So, and then going back, and walking back, again, remember in onCreate, that's where we're going to call get LoaderManager. That's what kicks this whole process off. And it may be also that you may need to call initLoader or restart loader in response to a button press. So you may see that as well. It's not always in onCreate, but you'll typically see that. As I kind of mentioned previously, so the whole framework implementation, if you just look at the, say, the LoaderManager class, the AsyncTaskLoader, all those three classes, you're going to see this message was deprecated in 28. It's a little bit of a different error message because you can see they say use the support version of it, which really for us, if you follow that, that says use the support library, you follow that link, and it says use Jetpack. So it's moved twice. So it's now in Jetpack. The good news is the Jetpack version works basically the same as the framework version did. So if you know how to use one, you know how to use the other. It's just you have to change what your namespaces and packages and such are, what your Gradle imports are. So that's the gist of loaders. There are some articles that I've linked and I put on perusal. They're here. The first one about exceeding the en-route speed limit. Definitely read up on that one. That will talk a little bit about that whole 60 frames per second, 60 milliseconds. That's where a lot of that comes from. There's also another article in there, the processes and threads guide, which will go over some of the fundamentals of working with threads in Java and how they connect to Android. So that would be those two things I would recommend you read between today and tomorrow. And then the third one is about loaders. That's one I would read in preparation for Wednesday. So those three you definitely want to read in the next few days. Any questions? Okay. So you'll want to get started with 7.1, again going through the tasks, the coding challenge, and the homework. All of those will deal with strictly the AsyncTask class, and we'll look at loaders in 7.2 on Wednesday.